Listen-only mode.
Hi everyone, my name is Liz Stanton and I'm a senior economist at Synapse Energy Economics. I'm going to be talking about 111D, components and implications of the draft rule for states. So we're going to start out with a few logistics. And I'm discovering I'm having a technical problem. Give me just a moment here, sorry. Okay, got it. Hopefully everybody just saw a slide change. That was the problem. Our webinar logistics, the slides are now up on our website. We left the URL right here. It's also on the home page of the Synapse website. You can find it there. Everybody's in listen-only mode, and we're going to be like that throughout the webinar, including the question and answers. We'll be doing question and answers using the GoToMeeting features. There's, over on your right-hand side, you have your GoToMeeting bar, and over there, one of the options is questions, and you can use that to send us questions at any time. I'm here with a few other Synapse staff that I'll be introducing at the end when we move into question and answers. They're going to be helping out with answers, and also we'll be taking a look at your questions as they come in during the presentation, and for ones that are clarification or things that we can answer in the moment, they'll be doing that. Okay. So a little bit about Synapse. I think many of the people that are on the line also already know a lot about Synapse, but we've been around since 1996 and do a lot of work on analysis of the electric power sector for public interest and government clients, and we're located in Cambridge, Massachusetts. Agenda for today's presentation, I'll be going through why do we have a 111D? Where did that come from? Talking about what I'm calling the currency for it, the emissions rate that is used for both setting targets and for measurement, the building blocks that are put together to get you to that target, what is being asked of states in terms of the targets that have been set, and then a little bit about EPA's estimated costs for states. Here's what we're not going to be covering today. These are all great topics and things that we'd love to talk more about and have an interest in ourselves, but they're not going to be part of our conversation today. We're just going to stick to kind of the nuts and bolts. We're not going to be talking about whether or not 111D is legal, whether or not it's good or bad for particular states. Not going to be critiquing the rule and how consistent or accurate it is. And we're not going to be talking about Synapse's points of view on the assumptions that are used to put together costs, emissions rates, dispatch assumptions, anything like that. We're just going to stick to how the rule works. So starting in with why do we have 111D in the first place? And I have a timeline here that we've put together that walks us through that. I'm not going to go over every word of these slides. It's more here as a reference for the people on the call. As I said, our slides are available up on our website and are there to be a resource for whoever wants to use them. Just quickly going through some of this material. Clean Air Act was enacted in 1970 under President Nixon, and there were some significant amendments in 1990 under President Bush that put together kind of the Clean Air Act as we know it today. That is the legislation that we have to limit air pollutants that might endanger public health or welfare. In 2007, the U.S. Supreme Court ruled that greenhouse gases are air pollutants, and therefore that EPA has an obligation to regulate them if they're found to endanger public health. And in 2009, EPA found exactly that greenhouse gases do threaten public health, and that for that reason they would now be regulating them. The first step in that began in 2011, and the step that's most relevant to what we're talking about today happened in 2012, and that was when standards for new sources for CO2 emissions were proposed under something that's called Section 111B of the Clean Air Act. And in that, there are emission rate standards that are set for new fossil fuel power plants. And the important thing to remember here, and why we're talking about it, is that when 111D is set for a particular industry and a particular pollutant, that triggers something called, when 111D is set, then that triggers 111D. And here we are having 111D for existing fossil fuel plants and for carbon dioxide. So the actual proposed 111D rule came out on June 18th. We've seen a draft of that a little bit earlier, but this is when the proposed rule came out in the Federal Register. It came out, yeah, on June 18th. And from that point, when it appears in the Federal Register, there are 120 days for people to make comments to EPA. So we've begun that period now, which ends on October 16th. From there, EPA will be issuing a final rule, taking into account those comments. State compliance plans will be due in June of 2016. And the final compliance date that is part of the proposed rule is 2030. So it has earlier dates than that of compliance monitoring, but it goes out to 2030. Under 111D, EPA must adopt guidelines requiring states to establish performance standards for existing sources of certain kinds of pollutants. And these are pollutants that would be regulated under 111D for new sources. Once there's a 111D, you have to have a 111D, and that is for existing sources. So we're talking about existing power plants in the United States. The way that EPA does this is by setting something called the best system of emission reduction, which ends up being called the BSER. And they take a few different things into account, determining what the BSER is for this industry and this pollutant. And here, the system in BEST system is defined broadly to include not just the generating units themselves, but things that are outside of the fence line and so do affect how much electricity is generated at those units. So it's a broad definition of what the system is, and the BSER sets the standard. This is not the first time that 111D has been used, although it is certainly the largest industry that has been regulated using 111D by far. But these are just a few examples of other industries and pollutants that have been regulated using the 111D provision under the Clean Air Act. Okay. That's just some background material to get people up to speed on why 111D has come to pass and why it's coming out at this time and what's happening next going along the line. Everything that I'm going to be talking about from here on out is explaining about how 111D works, but also I'm narrowing it just a little bit. And so within the proposed rule, which is a very long document with all of its attending pieces, there are several different options for 111D that are mentioned in there. And what I'm talking about here, to be specific, is I'm talking about the proposed rule that was just issued. I'm talking about in there option 1. I'm not going into option 2. Option 2 is very similar. Much of what I say is also true for option 2 here, but some of the requirements are just a little bit different percentage number in it. So this is option 1. And also, if you've looked at it, I'm sure you've seen that EPA has also posted some results of modeling having to do with just sort of partially doing one or the other of these options. I'm looking at the full all building blocks and option 1. So just to put this in context, if you've already reviewed the rule. That's what I'll be talking about here. And I'm focusing in on what is called the 111D emission rate. It's a special emission rate just for this purpose. It's not anything else. It's not a fossil fuel emissions rate. It's different from that. It's not anything we've seen before. It's its own special emissions rate, and that's the focus of the rule. So it's measured in pounds of CO2 per megawatt hour, and it is the same emissions rate with the same formula that is the currency for both the targets and for the compliance. It's same formula is used for the initial year to say what's our baseline. And you'll have noticed if you've reviewed the EPA's materials that actually there are two 2012 emissions rates that are published in there. One is just the fossil fuel rate, and it's not analogous to, it's not using the same formula as the rest of the 111B emissions rate work, but it is published in there. But for 2012, we start with a 111B emissions rate using the same formula for 2012. There is a target that's set using the same formula for 2020 each year through 2030. And these are the achievable emissions reductions based on the BSER that we were just talking about. And the same formula is also used for compliance. How is compliance going to be measured in each state and each of those years based on actual performance? So once we understand how this formula works, it can be applied to all these different uses. It's the same formula, but different numbers are plugged into it to get these different results. Okay. And here on this slide, and if anybody is following on the slide deck and not on GoToMeeting, I'm on slide 18. I've written out the formula for the 111B emissions rate. And I'm going to go through it piece by piece. So in the numerator, on the top here, we have fossil fuel emissions. And it includes a lot of things that are what you expect to be in fossil fuel emissions, from coal, natural gas, oil. For cogeneration, it includes the useful thermal from that. This also includes a certain portion of emissions that are coming from natural gas generation that's under construction today, but isn't yet completed. So it does have a specific treatment of that. And in 2012, in 2012, the measure as it's placed into this formula is the natural gas emissions that are actually happening in 2012. But in future years, we expect that the under construction resources will be completed. And the tricky part about this is that those would be covered under the new source performance standards, not under existing resources. They're not built yet. But part of this measurement is taking our existing natural gas DC generation fleet and bringing it up to a higher, what's called the capacity factor. I'm abbreviating it CF here. And so what's included in the numerator here for those units that are under construction, when they come into operation, is taking their capacity factor, how much they're used, over and above what an expected average would be of 55%, and bringing it up higher, usually to 70%. We can talk more about that. In the denominator, we have two sets of things. So down in the denominator, on the bottom half of the equation, on the left, there is fossil fuel generation. And that is made to match the fossil fuel emissions on the top. It's the same stuff, the emissions on the top, the generation on the bottom. But you'll see in this equation that that's not the only thing in the denominator. In addition to the fossil fuel generation, we have three other items that are in the denominator of this equation. And those are a couple things about nuclear generation. And the way that this is put in is that starting in 2020, so if you calculate this for 2012, it wouldn't be there, but if you do it for 2020 as either as the target or the compliance, it would be that you put in 5.8% of the use of nuclear that had existed in 2012. So looking at the fleet of nuclear that existed in 2012, 5.8% of that is still in use. And then in addition to that, you put in here anything that's under construction today or that has any new construction after 2012 would come in here as long as it's in use, once it's in use. Also, being placed in the denominator of the equation is renewable generation. And this is all the different things that we think of as being renewable. The only thing that is particularly drawn out as being excluded is hydro that is existing in 2012. New hydro, when that comes online, could be put into the equation for a particular year. Existing hydro would not be. And then the final item going into the denominator is energy efficiency. And the measure used is similar for the targets and the compliance. It's all worked out in a very slightly different way, but it's basically cumulative starting in 2017. It does take into consider sunsetting. So if you were looking at 2020, it would be those measures that were still in use. When it comes to compliance, then states can claim recognition for impacts in 2020 or in whichever year that were put in place after the release of this rule. So after June 2014, anything after that could be put in if it's still in use. So that's where the sunsetting comes in. But the targets only consider, when they're setting the target, it's only considering 2017 and on. When it's looking at 2012, it takes the value to be 0. So for the initial year, it's not taking any credit for existing EE and putting in the denominator here. So those are the basics of the formula that's used in these different applications to figure out what's our emissions rate today, or was in 2012, the baseline. What are the targets that are being set for each state? And these are what is each state being asked to do, what emissions rate is it being asked to get to, and then when we're out in those years, this is how it would be measured to say, have you achieved that or not? And you don't have to achieve it in the way that has been set out by EPA, using specific measures, a certain thing in the numerator, different mix of things in the denominator. But you would have to get to that end result, get to the pounds per megawatt hours that come from that formula. Okay. Oops. So, all right. The next thing to talk about is the ingredients of 111D, and these are what EPA is calling the building blocks. So there are 4 building blocks. I've broken them down into a few more because some of the building blocks have a few different measures under them. We'll start with building block 1. And this is for each state to reduce its average coal emissions rate by 6%. And you can do that in any number of ways, but the end result would be achieving that. And importantly here, this is how this is an explanation of how the targets are being set. So part of what's assumed in what can you achieve in your 2020 or 2025 or 2030 target is that you would be following out these courses of action. If you did all these things, what emissions rate EPA, or what 111D emissions rate could you achieve? Given a number for that, and then you go ahead and have the measures that seem most cost effective or meet other goals as best you can in your state in order to achieve that rate. You don't have to do the exact thing, the exact building blocks that are set out to set the target. The second building block, in building block 2, there are actually 2 different pieces of this, both having to do with redispatch of natural gas. The first is redispatch of existing natural gas. And so in most, even in all states, the average capacity factor, and again, that's how much the particular resource is being used out of its total ability for use, its total capacity, how much of that is actually being used. That the capacity factor, if you used it all the time as much as possible, it would be 100%. Most capacity factors for all resources, and for natural gas certainly, are much, much lower than that. And so the idea with this one is, what sort of emission reduction would you achieve if you raise your natural gas CC capacity factor up to 70%? And when they're figuring this out for the targets, they only raise the capacity factors as far as they can go by what's called redispatch, or by changing dispatch from coal and oil to natural gas. So for states that don't have enough coal and oil to not run, not dispatch, then instead they would not make it up to 70%. And getting a question here about a little bit more about what we mean by redispatch. So let me try that again. The idea is that we have a lot of different resources that are in operation in each state of different kinds. And you imagine a state that has coal, oil, and gas resources all running. What would happen with redispatch is that if otherwise coal or oil generators would have been run to make the electricity. Instead, we make the same amount of electricity, but we switch it over to using natural gas instead. So the dispatch is the running of a particular plant. Redispatch means instead of running this plant, we run that plant instead. And so when they're figuring out how much redispatch you could have from coal and oil to natural gas, they only redispatch as much as there is. So they're not going to increase natural gas running up to 70% of its capacity if it's the same idea for building block 2B. Again, it's redispatch to under construction natural gas. Now, the natural gas CCs that were under construction in 2012 would fall under the new source performance standard, but that would be up to a 55% capacity factor, using 55% of their possible capacity. If they are redispatched to use still more, up to 70%, then that 15% difference could be used, is used towards setting targets and could be used towards compliance. Are we okay with this slide? No? Okay, I'm just going to keep going. What are you doing to? Okay, having a little problem with the slides. Hopefully it's something we're seeing and you're not. So building block 3A, I've got 2 bits of that. This is our nuclear. And so building block 3A for the existing what's called at-risk nuclear. This is about existing nuclear throughout the country that every state that has nuclear in it is given in its target 5.8% of that nuclear capacity, and or of the nuclear generation, I should say, and they're expected to meet that as part of its effect on their final target. And sorry, are we doing this? Okay, thank you. And the second part of that building block 3A is for the credit that's given for nuclear under construction. So those 3 states that currently have nuclear plants under construction are given credit for that in their target, and so that becomes part of the calculation that sets their targets for 2020 to 2030, the existence of that nuclear under construction. For the building block 3B, this is for renewable generation, and this includes both existing and new, except for hydro, where existing hydro is not included, but new hydro is. And the final building block is the energy efficiency building block. And I explained a little while ago that when setting the targets, it's cumulative from 2017, although it does take into consider that the sunsetting, which means if it's not being used anymore in 2020 or 2030, it's not part of it. It's only things that are still being used. And I had mentioned that when it comes to measuring compliance, the states can take credit for any measures that are put into place after the release of this rule, so after June 2014. When the initial value, the 2012 111D emissions rate, is set for each state, the value for energy efficiency is assumed to be 0. It's not including any efficiency in 2012, begins after that. Okay, so this is just to remind you of the formula for one moment, remind you of what's on the numerator, the emissions, and what's on the denominator, the various different categories of megawatt hours. I've got a question here, but I'll answer that in 1 second. And this building block 1, that affects just your numerator, just the emissions. Building block 2, both parts of it, it has an effect both on the numerator and the denominator. It has a little bit of effects going on in both. For building block 3 and 4, these are things that affect just the denominator. And this right here, how these different building blocks are affecting different parts of the equation, that's part of the reason why we need to be a little bit cautious in how we're talking about what different states are being asked to do. And I think this especially becomes complicated when we're seeing these, the targets for states being expressed in terms of percentage reduction, that the calculation on that is actually difficult to do in a way that is accurate and providing helpful information, because different building blocks actually affect the equation in different ways. the question I was asked to clarify about in the moment was whether building blocks are required. The only thing that's required is to hit your target in the target year. You need to achieve your 111D emissions rate according to this formula in that year. Whatever has been given as a target in the final rule, you would need to achieve that. How you achieve that is entirely up to the state. And so the building blocks are there to set the target, and these building blocks do represent things that would change your 111D emissions rate. They're all things that are part of the formula, and so they're likely to be part of your strategy, but it is not at all required to do a particular one of any of these. You don't have to reduce average coal emission rate by 6% or any one of these things. What you do have to do is hit that final result, is achieve that pounds per megawatt hour target in the given year. So let's move on to talk about what states are being asked to do. And I've got some images here that hopefully are helpful in understanding this a little bit. Let me talk you through this, and then we'll be seeing a lot of similar images that all have the states going across the bottom. In this first group of images that I'm showing you, I'm showing two things. One is the initial 2012 rate, that's the high one, the brown, and the lower value that you're seeing is the target 2030 emissions rates. I'm going to focus on 2030. There are targets for each year from 2020 to 2030. To simplify here, I'm just talking about 2030. And just as a reminder, I'm just talking about option 1 and talking about doing all building blocks. So you can see here that the U.S. average is highlighted over on the right, and for that, the initial U.S. average 111D emissions rate is about 1,500, and the target 2030 emissions rate is about 1,000. So the difference, and this is what I'm calling the ask, this is what states are being asked to do, the difference is 500 points, or a movement of 500 on this 111D emissions rate in pounds per megawatt hour. So 510, there it is, bracketed. I'm going to move to a little bit different viewing of this that we're going to stick to for quite a few slides here. This is just looking at the difference. This is the difference between where you're starting out with your initial 2012 and that target 2030 that you're being asked to achieve. And the colors here are the building blocks. And so each state is broken down. Here's your ask. You can see over on the right for the U.S., that's that 510, that's the U.S. average. And the U.S. average is not actually given a target, but we're using it as an example here, that these would be the building blocks that are put together to come up with that target. That's the purpose of these building blocks, setting them up in this way, is it gives you the target, and from there, you can reduce your emissions rate by 510 in any way that you want, but you do need to reduce it by 510. That's how the rule works. This map shows the same information in terms of the difference, the size of the difference. So for the U.S. average, it was about 500. You can see that there's a range across the different states. The darkest ones have the largest ask, the largest difference between initial 2012 and the target. And the lightest colored ones, the kind of white, are the states that have the smallest ask. There are two areas here that are in yellow or orange. One is Vermont and one is Washington, D.C. The rule does not apply to those two, that state and that district. And that's because there are no fossil fuel plants that fit under the qualifications in either of those places. The qualifications for fossil fuel plants under 111D have some limitations about very, very small plants are not included. So that is part of the rule, but Vermont and DC don't have any plants that are above that size. Okay. So just going back to this is going to be kind of our focus to look at how are different states affected by this, who's being asked to do what and why. One thing that I want to focus on looking at this is we've got the 510, that's the U.S. average, with a line going across so that we can see that. What states are above that and what states are below it? And that's going to be kind of the organizing principle for the slides that I'm going to go through now, is to say which states are diverging from that quite a lot. Okay? So walking through the building blocks one by one, this is building block 1, the lower average coal emissions rate, and those are the green blocks on the bottom. Just about every state has some coming from this. The states that don't have any coal generation that was in operation in 2012. It's spread across all the states, though, all other states. This is the building block 2A. This is redispatch of natural gas. And you can see this is a pretty big item in terms of how much it's providing of the entire difference amount, the ask amount. I've highlighted some states in red. These are ones where this component, the building block 2A, redispatch of existing natural gas, is a large one. It's contributing a lot to the entire amount. And also that when you look at what their capacity factor, how much they're running to those natural gas DCs, is very small in comparison to other states. So just to give the comparison here, this graph is showing natural gas capacity factors average for each state. The states that don't show them is because they don't have any natural gas DCs, or they weren't running in 2012. The redispatch is to get each state average up to 70%. It is possible to do that by redispatching existing coal and oil. And you can see that some of these states are well below that, and others are a little closer to it. Back here, the red is highlighting states that are pretty low in terms of their, comparatively, in terms of their natural gas DC capacity factor. And also it ends up being a lot more that they can accomplish by moving up to a 70% capacity factor. They can have a much bigger emissions reduction from doing that if your current capacity factor is pretty low. This next one is small, so it's hard to see, and that's the 2B, redispatch to under construction natural gas. There is some, or there was in 2012, some facilities under construction in that year. But as we talked about, it's not the entire amount of generation and associated emissions change that would go into this formula. It's just the difference above the expected 55% capacity factor. So up to that 55% capacity factor, that facility is covered under the New Source Performance Standards. Above 55%, up to attempting to reach that 70%, the redispatch, that would be covered here, and those are the very small bars that you see. The next one is the first of the two nuclear 3As, and this is what's called the at-risk nuclear. And you can see a lot of states have nuclear. Any state that has nuclear, 5.8% of that nuclear is shown here. And that's just sort of the rule of thumb that's being used. This is the second part of the 3A building block, the under construction nuclear. And you can see just 3 states, Georgia, South Carolina, and Tennessee, have nuclear at this time, or in 2012. They had nuclear under construction in 2012. And for those 3 states, it ends up being a pretty big building block in comparison to their total ask. It's a big contribution to the total amount that's being asked of them for the 2030 target year. I should say, I neglected to mention this before, but the numbers that are next to the state names, those are the ask. They're the difference for that state between the initial 2012 emissions rate and the target 2030. And you can read the numbers off of there. But for each of these states, the 3A2 under construction nuclear building block ends up being a significant portion. The next is 3B, that's our renewables, shown here in yellow. And you can see that every state has a portion of this. And every state is not being asked to do exactly the same thing in terms of the share of generation from renewables that they're being asked to achieve by 2030, it varies by region. So the regional goals are set based on current regional renewable portfolio standards. Those were put together to come up with sort of an average regional goal, and then that goal is applied to each state in the region, and that becomes what's asked of them in terms of renewables, that they achieve that. And so, of course, for states that have more ambitious renewable portfolio standards, that ends up being a larger, if they're in a region that has that, it ends up being a larger ask, and for states that are in a region where it's smaller. You'll see 4 states on here that are negative, which I know is a little bit confusing. And what's going on with those states is that what they're being asked to do in 2030 is actually smaller than what they're doing right now for renewables. Their current renewable generation is smaller than what they're being asked to do in 2030. And the reason that came about is because that state must be in a region where the regional goal and therefore the renewable portfolio standards of other states in that region are less ambitious. So it's in the state is in a region where the targets are less ambitious. Its own achievement has been more ambitious, and so it ends up ahead of the game. And so what happens is that they get credit for that. And if you look at Iowa here, the way to read this is you can see that the total ask, the difference between the 2012 and the target 2030 emissions rate is 259. But if you follow the bar up, it looks like it's above 400. That's because to get the true value for any of these states that have a negative for renewables, you need to add together the negative part and the positive part. The negative part gives them a credit and reduces the total amount that they need to do. So it's a bonus in the sense that these states will be asked to do less on other things because they've done so much already on renewable. It's these 4 states, Iowa, Maine, Minnesota, and South Dakota, that are in this position currently. The final building block number 4, is the orange blocks that you see here, and this is the energy efficiency. By the time we get out to 2030, the cumulative energy efficiency targets in terms of the percentage of sales that we're looking for a reduction in sales of a certain percentage. They're all very similar between states, kind of between 9 and 11%. So that's not what's making the difference. It's more a difference in the other things that are going on in the state, and I'll show how that works in a second. I wanted to pick out, to explain this a little bit, the example of California and Illinois. And if you look on here, those 2 states, the amount that energy efficiency contributes to their difference between initial and target, to that ask for 2030, is quite different. The Illinois is more than double what the California's is. But I want to use this as a moment to caution against looking at either the total ask or a particular building block component and comparing it to another state and saying the state's being asked to do more, the state's being asked to do less. It doesn't quite work that way. And certainly, these values that you see here for energy efficiency, how much is being asked in terms of the reduction in the 111B emissions rate, is not proportional to cost. So it's not something that should be assumed, look, Illinois is bigger than California, they're being asked to spend 2 or 3 times as much. It's just not the case. Let's walk through that a little bit. So I've got a few things up here. On the top, this is just repeating those orange bars, but setting them up next to each other, you can see that the Illinois is much bigger, more than double the California's. That's the top bar. The impact on targets in pounds per megawatt hour. On the bottom, I have the EE impact. Again, this is the 2030 EE impact, energy efficiency impact, in gigawatt hours. So this is looking at how much each state is being asked to reduce its sales in gigawatt hours. And you can see that the California is actually being asked to do more than Illinois. It's going in the opposite direction. And this is why I say that the impact on the target is not proportional to the cost. Quite the opposite here. So if you assume, as EPA did, that every kilowatt hour of energy efficiency savings costs the same within a year. They do change it over years, but that costs the same everywhere for every state, regardless of kind of how much they've done so far, then actually the bottom graph here would be proportional to cost. That if you graphed out the cost, it would have exactly the same pattern. California's would be a bit bigger than Illinois', but not that far out of scale. Completely different from what you see in terms of the target impact, where Illinois is double or more that of California. So more work needs to be done to figure out what the costs are than just looking at the target impact. It's more complicated than that. Okay. So those are the 4 plus their subparts building blocks, all put back together here in this graph on slide 41. And what I've done in the previous slides, if you go back to them and look at them at some point, is that I've tried to pull out all of the states that are above the U.S. average, above that 510 pounds per megawatt, and say, why is it that this state is above average? And I've hit pretty much every one of these states as an example in the past few slides to say, why is one bigger than another? For some states, it's because they have nuclear under construction, and that ends up being a large block. For some states, it's because their capacity factor for their existing natural gas combined cycle plant is very low, and so they have a long way to go, a lot of opportunity to get to 70%. And in other states, it's other things. So it's making sense of why some states are being asked to do more, or conversely, some states are being asked to do less. When you think about the states that have already gone beyond their targets for renewables, are then being asked to have less asked of them in terms of their target in 111D emissions rate. So just a few more slides, and then we're going to open it up to questions. These slides are about EPA's estimated cost of 111D for states. And so what I'm going to be showing you is based on EPA's estimated cost, coming directly off of that. Where I've made any assumptions in addition to that, I'll explain what those assumptions are. But that's the context of that, is that as part of releasing this rule, EPA also releases its estimation of the cost of the rule. So this is broken down. It's exactly the same information that you can find in the rule documents. I've broken it down in a little different way. And so the first top band that you see up here, I've put the different kinds of costs that would affect your electric rates and your electric bill. The things below that have other effects that are real and important, and we need to think about those too, but I'm just separating out the things that are affecting your rates and bills and the things that aren't. So the top one, the electric sector, these are effects that would be both felt by people that were participating in energy efficiency programs and those that weren't participating in energy efficiency programs. This affected everybody that is getting electricity from the grid. And on the benefit side, this is really kind of a mix of costs and benefits. This comes from the IPM modeling of the electric sector that EPA has done of the proposal. And that IPM modeling, when all is said and done, comes out with a benefit of $34 billion of doing all the things that were needed to do in 2030 to achieve these state targets. And the reason that it comes out as a benefit is because there is a lot of energy efficiency in there, and so a lot less electricity is being generated than in 2012. So that's a benefit, 34. And then over on the cost side, things that would be negative from that, the cost to administer energy efficiency programs would be $21 billion. And if you take the difference, you come out with a net benefit of $13 billion, which is about 0.3 cents on each kilowatt hour, and that is a reduction. So this is a benefit to all of us that are paying electricity bills. It means our electricity bills would, for each kilowatt hour, be 0.3 cents lower. There are other costs and other benefits involved, however, and so for people that did participate in energy efficiency programs, that would be the same effect on their rate, how much they pay per kilowatt hour, that they get that reduction, and everybody would feel that. But people that were participating in energy efficiency programs would also have lower bills because they would be buying less energy. Their bills would be lower. They'd also have some special costs because most energy efficiency programs around the states there's some contribution from utilities that comes out of your rates, but there are also parts that program participants pay in themselves, and so that's in here as a negative cost. There are also a lot of benefits that EPA is looking at. They're looking at climate benefits that are actually benefits around the world that come from reducing greenhouse gas emissions. They're looking at health benefits just within the United States. They actually list and discuss more health benefits than they actually add up dollars for, so this is a partial accounting of the health benefits here. You can see that altogether, when you put together the electric sector benefits and costs, the energy efficiency program participant benefits and costs, the societal benefits and costs, that we end up with a whole lot of net benefits. And that's what the EPA is concluding, that there is a big net benefit from doing this. I want to point out that not only is there a total net benefit in all these different realms felt by society as a whole, people that participate, people that don't, but specifically if you look just at rates, just at what's happening in the electric sector to rates, there is a benefit, and that's a reduction of 0.3 of 0.3 of a cent per kilowatt hour. And it's that piece that I'm going to talk a little bit more about for the state. A couple of caveats about how this is done, just to point out that the whole exercise that's done by EPA in terms of setting up the building blocks and figuring out the targets is not a least cost exercise. They're not trying to figure out what would be the cheapest way to do this for anybody. They're figuring out what is doable, what's reasonable, not so onerous as to present a kind of economic threat to the electric industry, but as much as we can do, and that's what the BSER standard is to achieve what we can do. No least cost analysis has been done, and the idea of this is that each state is given their target that they need to achieve, and those states will go out and figure out what's the least cost way for you to achieve that target. And that analysis just hasn't been done yet. The costs that are presented here are not the least cost. No effort has been made to figure out what would be the least cost. Presumably, a lower cost could be achieved. EPA points out that at the very least, states are permitted under this rule to band together into regions, and that if they did that, that each state's cost would be lower. It would be lower to do it as a group than it would be to do it one-on-one each state. So those are important considerations in looking at what these costs are. That's not least cost. I'm presenting some estimates state by state. EPA does not do that, and there's some good reasons why they don't, having to do with their modeling. Here are the assumptions that I use to be able to do that. I'm assuming that EPA's average national cost by building block holds in every state. Every state pays the average national cost. I'm not following their IPM modeling methods. I don't have the ability to do that here or have that model in front of me, and the model is not well suited to doing state-by-state results. And instead, what I'm doing to match EPA's national costs is that I'm adjusting the avoided cost of energy. So every time you don't generate something, you don't generate some, you don't run your coal plant, or you don't run whatever kind of generation because you're using energy efficiency, how much is saved? I'm adjusting that avoided cost of energy to match the EPA's results. And that's how I get to these state costs, estimated state costs. So again, what I'm showing next is just the electric sector. I'm not showing those energy efficiency program participants, the cost to them. I'm not showing the societal benefits. I'm just showing what would come out as a rate impact. Okay? This is in millions of 2011 dollars for 2030. What would the cost of compliance be state by state? It shows that for all states but 2, it's a benefit. That's what the negative cost is. It's a benefit to you. This is that you would have reductions in rates in your state. There are 2 states, Arizona and Arkansas, that are going in the other direction. They have a small increase. I've also done this dividing it through by the expected generation in 2030 to come up with a cents per kilowatt hour measure of these costs. And you can see that the benefit to states is all less than a cent per per kilowatt hour, and the two states that have costs are less than 0.3 cents per kilowatt hour. And this is how that works. So again, this isn't based on the same kind of modeling. It's just using their results and running the numbers from that to see more or less what it would come out to. And these are not least cost estimates. These are just the estimates using the building blocks without any attempt to figure out what would be a most efficient way to do it. Okay. So a little bit late, but I think we made it to the question and answer period. And I do have more people actually in the room that are up on this slide, so I may be fielding questions to a few different people that we have here. And maybe we'll just jump into that. Is that, yeah? Okay. So if you give us 1 second to be able to see your questions up here. I know that Sarah Jackson has been answering people while I was talking. There we go. And great. Now we can see things a little bit better here. So, Sarah, do you have anything to say about this? Or I wasn't able to get the flags working. Okay, so we're just reading questions out. We're just going to go in order here. I know that there probably have been some questions that people have gotten a response to saying, well, that's not really in the scope of what we're doing today. We said there were certain things that were out of our scope today. We'd love to talk to anybody about that. You're welcome to email me or email somebody else at Synapse to delve into those issues. It's just not what we're doing in this presentation. So I'll be picking questions that seem to be within our scope. The first question that I'm seeing on here is this one right there. Okay. Why is methane emission regulation outside the fence line? Oh, no. Why is methane, do you want to read it?
Yeah, this was a question from Tony and Gracia, just asking why methane is not included in this proposal.
So methane from extraction, is that right? Go ahead.
Yeah, and this is, EPA just chose to focus on CO2 for this regulation.
Yeah, it's a CO2 regulation.
But that's a simple answer.
There's more complicated answers to that, but this particular regulation is just about CO2. Okay. This is just you going back and forth with him. Okay. Sorry, I'm learning how to use the question feature here and figuring it out. Okay, will the slides be available? Yes, hopefully the slide that you can see right now shows the address, and slides are also available on our homepage, on the Synapse homepage. You can just Google that if you don't know the address. How is EE proved? Sarah, you're a good one to answer that. Are you not? No?
I don't think I am. But
anybody else in the room for how it's proved, what kind of studies that are going to be used in that? So I'm thinking that if everybody in the room is shaking their head at me, that we did not find that in the rule. And between all of us, I think we've pretty much read the thousands and thousands of pages. Mostly Sarah and Max and a couple of people and Jeremy. So we don't think that that is addressed in any detail of how it's proved. Bruce, do you want to say anything about that? How would EE be proved in compliance?
Just, I expect it would be standard, monitoring, verification protocols, the sort of things utilities have been doing for years, engineering and statistical analysis. But I'm not positive.
That's what we're all expecting, but it's not shown in there. And I can tell you that states will be allowed, I think I said this earlier, to use any measure that's been put in place, this is for compliance, any measure that's been put in place after the release of the rule, after June 2014, you can put anything that's been put in place and is still in use in the year of compliance. That is in scope, but no, we don't know. Sorry? How are, oh, is this the next one? Yeah. Okay, thank you. I'm trying to help you. I think I skipped over one. How are electricity imports treated? Okay. I can do a little bit on this one. So the one place that I can answer this about is in EE. Maybe somebody else in the room has an answer in other ways. So in general, this is a rule about generation in your state, on ground in your state. And let me make two exceptions to that. So one, in terms of EE, that for target setting and for compliance, if your state is an importer, a net importer of energy, then the amount that is expected of you for the target and the amount that you're giving credit for compliance of EE is reduced by that share. So if, say, California only generates 70% of its own energy within the state, that after the EE number has been figured out, a certain percentage times the retail sales in a certain year, that that number is reduced to 70% of its value, and that is the value that's used going forward. If you are an exporter state, no such adjustment takes place, only an adjustment to importer states. The other thing that I wanted to say about this that I hadn't mentioned before that touches on imports is regarding renewables. So a question comes up with all of this. When we say renewables in a state, what do we mean? Very often with renewable portfolio standard policies, the answer is that there are what are called RECs, renewable energy certificates, that are bought and sold that very often can be bought from another state and used in that state to comply with a particular regulation. And a question comes up in here, when we're talking about renewables, do we mean renewable generation on the ground in your state, physically in the state, or do we mean things that you have purchased in terms of buying those RECs? And the answer, as I understand it, is that this is a question that EPA is asking for comments on. They are specifically not saying which of those two things they're referring to, and instead are saying, we would like to get comments on this. Should we do this based on in-state generation, or should we do it based on REC purchases? Please advise us. So those are the two things I know about imports. Anybody else?
Well, I would just point out that it's mainly an in-state rule, so you can comply state by state, and because it's done in terms of rates and things like efficiency are just adjustments to the denominator, it's basically done in that 111D emission rate fraction. Mm-hmm. So to some extent, the answer is it doesn't really deal with imports. They're not part of the picture. This is kind of a state-by-state thing.
It is, yes. So it's very much generation-focused, and those two things that I mentioned, one for EE and one for renewables, are two things that may or may not end up being exceptions to that. What's our next one?
We had a couple of questions on nuclear. Where we may try to point them out, but it's
great. Sarah Jackson is organizing your questions and keeping us from answering the same question over and over again. Thank you.
So essentially, people were seeking clarification on how nuclear was treated in that building block. So there was a question about why 5.8%, and then another one just sort of saying, could you explain how nuclear is treated?
Okay, so this is about the existing nuclear, right? Not the under construction nuclear, I think.
Yeah,
right?
Well, just in that building block.
Okay. So the idea, as I understand it, and other people here can correct me, is that EPA has looked at how much nuclear generation there was in each state in 2012 and has separately determined that about 5.8% of U.S. nuclear generation is at risk for 2030. That determination was not made state by state, it was made nationally. So 5.8% is at risk by 2030, at risk meaning would no longer be in operation. And then they are taking that 5.8%, multiplying it by the 2012 generation for each state, and it goes into the formula in the denominator. And the idea then would be that if something goes into the equation in the target, you are being asked to do that. You're expected to do that. And then if you are, and here what you'd be expected to do is instead of having that nuclear shut down, to take action to make sure that it's still generating in the compliance year. So through this could end up being an incentive to keep those at-risk nuclear plants in operation in years where they thought they might be shut down. That's the logic behind it. The part that, all good. The part that may not be intuitive is that the 5.8% is a national number. There's been no determination that 5.8% of nuclear is at risk in each state. However, that's how the formula is applied in terms of setting the target. It's set as a blanket 5.8% across all states. I think that was the question? And then separately, under construction nuclear, the whole amount goes in. So these are all things that would change your emissions rate. So having a new nuclear plant built would change your emissions rate. Preventing a certain amount of nuclear from shutting down that would otherwise have shut down would change your emissions rate. Yeah?
Yep. And then there was also a question about the exclusion of existing hydro.
Right. So new hydro is in, but existing hydro is out. Did anybody read anything? Was there any why?
Yeah, but essentially EPA was saying that to use the existing hydro to build out the building block for what's possible in other states would disadvantage states that don't have the massive hydro capacity that some of the existing hydro reflects. So they left it out. I think as with everything, they're open to comment on the treatment of this. So,
So,
yeah.
Where do we go now on the question?
I know we've gotten a bunch of extra ones that I haven't.
Okay, should we just start heading down?
So there's a question as to whether the IPM model took into account upward pressure on natural gas prices as redispatch moves towards natural gas.
Are you down here on this David Woolley question? Is that
Down about 5 from the bottom.
I'm not sure what you're saying. Why don't you just go ahead?
I'm asking you a question. There's a question. There's a question as to whether EPA ended up looking into IPM modeling that would allow natural gas prices to flex upwards with increased pressure on natural gas.
Okay. Yeah, we have a couple questions about that in here. About.
And do we know if we saw that within the RIA?
I did not. Anybody else? Anybody about price sensitivities in general? Price sensitivities? No?
But generally, I believe that is built into the IPM model.
In general, it is, but I'm not sure how it's flowing out through the results. So, yeah, we don't have the answer to that. And if somebody else does out there among all the people that have been working on reading this, we'd love it if you emailed us the answer. We can share it around. This is something that we don't have a handle on yet. Okay. What assumptions are you making in terms of EE participants? What level investment are you assuming has been made? This is for
I think it's what is assumed in 2012 for the existing levels of EE investment.
It's a little bit complicated. So when we're talking about the measurement, I'm not sure what you're saying there. When we're talking about, go ahead, when did you do it?
For EE, no, I think they just essentially were looking at the levels of EE that are existing in 2012, and they bring those levels into 2017, which is the starting year for the calculation of where you need to be by 2030. So there may have been more to your question, but I'm not sure if we can answer all of that at this point. But I think certainly send us some emails if we want to continue these conversations. I know we have a lot of questions.
Yeah, that's great. Thanks, Sarah. And we're still learning about this too, and trying to figure out all the ins and outs, and kind of doing our best to present that to you here. So we're glad to continue the dialogue and to learn more about what people on the line have figured out about these particular provisions. Can I do that one? How would there's one here, how would an RTO state like Maryland achieve redispatch of coal and oil plants? That's a good question. What I can say about it, from what I've read in this is in one of the technical documents, says that what's expected regarding redispatch is that states would put in place a charge of some kind, a tax or a fee, that would add to the cost of all generation units that had emissions rate greater than, I think it says 1,100 pounds per megawatt hour, and that through that fee or tax structure or allowance structure, whichever one it is, that would have this effect of emissions, sources of emissions generators that had higher emissions than 1100 would be disadvantaged in the market in comparison to those resources that were lower than that amount. Go ahead, Bruce.
And you can imagine Maryland going this alone as a state and having such dispatch adjustments made that it might then put into generator bids into PJM, right? So the RTO. Or you can imagine Maryland joining with other states, presumably in the PJM, and having the redispatch done on a regional basis. But either way, for the same mechanism in terms of dispatch adders or subtractors to the plants based on their emission rates.
And that's something to remember with all these things, that is absolutely a part of this rule that states can combine together. And EPA is suggesting that costs could be lowered by doing that. And so when you're thinking about what any of these building blocks mean, there is the possibility that in putting together its implementation plan, that a state could, rather than make an implementation plan just for itself, to band with other states, and in that combine the target, what's being asked of them, and then meet that target jointly. Yeah. Go ahead, Sarah, you have one here? That one? How does implementation ramp in between 2020 and 2030? Linear or based on a BSR feasibility type of panel, accessibility to average? If I'm understanding the question, then the targets are set individually from 2020 to 2030. It's not a linear ramp. So it's set based on BSER plus feasibility, as you say. The BSER feasibility is set for each of those years. Building block by building block, some of the rules for how it's done in a particular building block are linear. But you couldn't say that the whole group of building blocks together, the final target is linear. That wouldn't be correct. Hopefully that was an answer to that. So, see, what is the EE offset? I don't know what that one means. What is the EE? What is the EE sunset? What I mean by the sunset is that we put measures in place in a particular year. Let's say we put them in 2015 or 2017. When you roll around to 2020 and that's a compliance year, or we're using that as a year to figure out what the target is, not all of those EE measures are still alive. Some of them have retired, if you will. So they're no longer in operation, and I'm saying that they have sunset. They were useful for a period of time, but by the time you get around to a future year, 5 or 10 years down the road, they're no longer working. They're no longer reducing the amount of energy that's being used, and so they have sunset. Which one? Any idea of how this will impact electricity rates in the short, medium, and long term on a kilowatt-hour basis? I don't have that. I did do, let me find it here. I did do something similar. I did one calculation for 2020, 2025, and 2030. Like I said, I did almost all of this just for 2030 for simplicity's sake. But for, here we go. Just on a national level, I didn't do this state by state. There's in that slide that shows the estimated national 2030 net benefits, and I divided it by electric sector, energy efficiency program. This is slide 45. Or also duplicated on slide 43. And here in 2030, I say that the net benefits that affect rates, so just for the electric sector, the ones that affect rates are $13 billion. I did calculate that for 2020 and 2025. In 2020, the sign is the opposite, so it's a net cost of $2 billion. In 2025, it's a net benefit of $9 billion. In 2030, it's a net benefit of $13 billion. I didn't do any other calculations over time, I'm afraid.
And the $13 billion worked out to 0.3 of a cent per kilowatt hour.
Using
the
EIA's expected sales for 2030, yeah. I thought that 2025 was the base year, so that
2005.
Sorry, that's it. I thought that 2005 was the base year, so that states will get credit for actions taken in recent year, but is that not the case? So it is not the case that 2005 is the base year. Everything in this rule is based off of 2012, and that means that kind of there are lots of interesting artifacts in the rule that are about the year 2012 that because things are based on the generation that happened in that year and the emissions that happened in that year, and then we use that as a backdrop to understand changes. If something was a little bit different in 2012 for a particular plant, that would kind of get captured in that. But it is that as the base is 2012. After all is said and done, after the targets were set based on that 2012 starting year, the targets were set for future years, and the whole thing with all the building blocks is all placed into the IPM model, and it's run, and we figure out at the end what we think the cost will be for the electricity sector. After all that is said and done, and we say, what will the emissions change be for the country, then that amount, those total tons, were taken and compared to the total tons from the electricity sector in 2005. And that's the 30% reduction from 2005. It's a, after the fact, here's a nice comparison kind of a number. It doesn't have to do with the base year. How are existing renewables treated in the 2012 calculation of the emissions rate? Is the regional goal used to add that amount of generation to the denominator? Existing in the 2012. Yes, so if let me just read this one more time to make sure that I'm answering the correct question. Existing renewables treated in the 2012 calculation of the emissions rate. Existing renewables are in, yes. So that amount of generation is added to the denominator. That's absolutely correct. And then as it's changed for different years, for 2020, 2030, what have you, then it's the different, what's changed is the difference. So anything that's changed since the 2012. The 2012 does have existing in it, with the exception of existing hydro. Right. Let's see. Any idea how this will impact electricity rate? We did that.
Yeah.
Any calculations showing the gross amount of natural gas used for power generation in 2012 versus in 2020 and 2030, assuming that's in their spreadsheets. You can find it in their spreadsheets, and if you want to write to me, I can probably lead you to where that is. So yes, there are calculations of that. I don't have something to show you, but yes. We had, I think that's, did we make it to the bottom?
Yeah, we made it to the bottom.
Okay, I think we're running out of questions. So if we missed your question, can you resend it? Because we think that we've made it through the questions here. Bruce, did you have something?
There's a question about whether it's linear between 20 and 2020 and 2030.
We did.
Oh, we addressed
yeah, we addressed that one. And what I said about that was that this is in terms of the targets that are set.
Yeah.
And yes, it's on a BSER feasibility basis. And so while some elements of it have been calculated based on a linear trend, the whole target itself is not based on a linear trend. It's put together from those building blocks year by year. Does new hydro added after 2012 get added to the denominator? Yes, it does. That's correct. And so just like any other renewable resource,
it'll be counted towards
towards compliance, and it will be something that helps you comply. Okay.
This is a new one.
That one up there. What is the effect? What is the effect of having not put EE into the 2012 calculation? That's a good question. Is it true that it makes it seem like the state has to do more than it really has to if you're in a state that is already meeting a 1.5 EE standard? Yeah, we've had a lot of discussions like that in-house here in terms of what kind of effects that has. I don't know if anybody here wants to try to field that. I'm going to go with it's complicated and not try to give a definitive answer here. I think that at least is part of the answer, or either that or I haven't done enough analysis to be able to give kind of a blanket answer like that. Anybody else? No? Sorry about that. If anybody else has an answer to that, please write in with it. Send me an email or give us some more information. Could you say more about how you got to the rate reduction estimate of 0.3 of a cent? Yes. So if you want to look at slide see, slide 43. So I'm using numbers that are straight out of the RA, straight out of the rule. And I'm separating out those numbers that are things that I understand to affect electric rates. And so that's everything that is put into the IPM model, which is a model of the electric sector. And when that model was run for 2030 and for option 1 here, the result was a reduction in total electric system costs of $34 billion. In addition to that, the EPA estimates that all of the energy efficiency programs will cost utilities and other kinds of program administrators $21 billion. So when you put those two things together, the 34 in benefits and the 21 in costs, we get a net benefit of $13 billion in 2030. And I divided that amount by the EIA's expected U.S. sales of electricity in 2030, and that's how I got the 0.3 of a net.
And there was a related question about whether that counts, the 0.3 cents counts the change in the kilowatt-hour sales. And I think the answer is that it doesn't, that it just seems the kind of base level of sales, and that's the cost delta divided by the total sales expected in 2030. And you could do another calculation that accounts for the rate-making effect of on the price of electricity sold, because there will be fewer kilowatt-hours sold in the compliance case.
And that's not the calculation that I did.
Correct.
And if you did it that way, then looking at tenths of a cent, it might be hard to observe it. It might change you to 0.4 cents. Yeah. Okay. Sorry, the questions keep moving as they come in. So is that just the effect of the EE aspects of the rule or the rule overall? You're talking about the 0.3 of a cent I'm getting from that. Is that the effect of the 0.3? It's the effect of the rule as a whole, but just those effects that are felt in rates. So there are additional costs of people that want to participate in EE programs and then have their bills lowered. Thank you. And have their bills lowered are, those are, sorry, too much going on. So if there are participants in EE programs that have their bills lowered by paying additional costs to do things, to put in new light bulbs, to put in insulation, what have you, that's something different. That's not in that 0.3 of a cent. There's also the benefits to us all, the benefits worldwide of averting climate change or avoiding a certain amount of climate change, benefits to us all within the United States of positive impacts on our health and welfare from reduction of certain kinds of emissions and other pollutants from power plants. Where are we? On slide 43 are the top two rows cost to consumers. So 21 billion and 21 billion for a total of 42 billion. Would that make it a net cost to consumers before you incorporate the societal benefits? Yes. So if you put all consumers together, and even, I mean, I'm not sure consumers is the word that we want here. So, but maybe it's everybody that uses electricity, right? So everybody that uses electricity within the United States from the grid is in that group, so it's a cost to that whole group. Basically, the United States as a whole.
So if you define it as, if you define the cost as the total electric system bills plus the participant contribution to these EE measures, and the assumption is the participants pick up about half the cost, and the utilities or program administrators pick up the other half.
In rates.
In rates. As you put all those together, you would add the other 21 billion of costs back in, and instead of a $13 billion benefit, you would get a $8 billion net cost in 2030, I think. What that excludes then is all of the other all of the other benefits that are outside of that. But that's not a crazy way to look at things. It's one way that one might choose to add up define the universe of costs that you care about and those that you're going to choose to ignore.
Right, but then what you wouldn't want to do with that is to take that and divide that by kilowatt hours or divide that by the number of people, because once you do it that way, then you want to consider that different people are feeling those effects differently. So, sorry, the one that's highlighted? Yes. There is some indication that EPA may have omitted existing sources in particular states. If EPA miscalculated a state's existing energy generation, say by excluding the operation of a 900 megawatt coal plant, how might that affect the calculation of initial state goals? Would you expect the carbon reduction goal to be higher or lower, and why? So I haven't heard this before, that some things have gotten omitted. I think there's two ways in which that could happen. And one is, as I said before, because the base year is 2012, based on a single historical year, that kind of artifacts from 2012 become embodied in the whole rule. So if something funny happened in 2012, like a particular coal plant didn't run at all, then that would be embodied in the rule. And it would be as if that coal plant sort of didn't exist. So that's one way that could happen. Another could be an error of some kind. I suppose that that's possible. The EPA says what their data source is, and for a lot of those numbers, I've matched it to the data source, and I haven't picked up on any of those errors myself. But of course, there could be an error in the data source. Anything's possible. What kind of effect would it have? I mean, I think there's a lot of different kinds of types of errors that you could have, and depending on the type of error, you'd get a different result. So, yeah, I'd be happy to think about that more and kind of think through different kind of error, different kind of result, but maybe we'll take that offline, and you can send me an email to talk through that a little bit more. Which one are we on? This one? Does the 0.3 cents per kilowatt hour electricity cost reduction include price suppression effects? Yes, my understanding is that it does, that when you model in IPM, that it includes all those different kinds of electric sector effects that you would expect in that kind of complicated dispatch modeling. Bruce, do you want to anything about IPM?
Just that we haven't opened the lid to look at it at that level, whether there are price suppression effects or whether they're, how big they might be and whether they're appropriately calculated. So basically, I'm going to say we don't, or not. No, we don't know.
That we don't, yeah, we don't know the ins and outs of it.
That's a good question.
Yeah, we don't have access to what's under the hood of the IPM model. Have you reviewed the reasonableness of the EE benefit estimate in terms of avoided costs?
Yeah, I'm going to say on that there isn't an explicit EE benefit estimate. There's IPM model runs. So to clarify, all that business that we were talking about of setting the targets by state is not done with the IPM model. That's done with calculations and basically a big database or spreadsheet. The IPM model runs that we're talking about now relate to the calculation of the cost and benefits.
And the final emission change. Mm-hmm.
Yeah, but that's not for setting the targets. That's for the analysis of that. And so then, and there isn't an explicit avoided cost calculation. There are IPM model runs, basically with and without all the things, typically compliance and non-compliance. Mm-hmm. And so, but within that, you might have questions. We go, are the power plant cost assumptions reasonable? Are the fuel price assumptions reasonable? Mm-hmm. And so on. And you know, we have not you know, gotten our hands really into reviewing that yet. So I mean, I don't have a particular comment on whether that's reasonable or not. It's basically done with the usual set of you know, the government's power plant assumptions and fuel price assumptions, and they do a pretty good job of providing documenting them. Mm-hmm. They tell you what they are, but we just haven't really dug in yet.
Yeah, exactly. And actually, since the release in the Federal Register yesterday or the day before when it came out in the Federal yesterday, there are even more documents that are now available, and so we haven't made a lot of headway into looking at that new release of documents. Please walk through what would happen to emission rate calculation with addition of new nuclear generation in a future year. So just generally, new nuclear is something that would appear in the denominator of the equation, the 111D emissions rate equation, as would a variety of other things could appear down there. If you have new wind or new what have you, that is something that fits in with the denominator where the megawatt hours are added up. So if you have new nuclear, then that would make the denominator of your equation bigger, which would make your ratio, your 111D emissions rate, smaller, which is what you're going for. So all the states want to make their 111D emissions rate smaller because they're trying to reach a target emissions rate that's smaller than their current one. So if you had future nuclear generation, you would put it down there in the denominator, and it would help you out towards compliance.
Right, and every megawatt hour would help you, I believe, in the exact same way that a megawatt hour of new non-hydro renewables would help you. It's in that same place in the denominator.
Yes, that's right. Where was the have you reviewed that? No, yeah. Simple out of states, that one. Simple out of states are getting a 1.5 annual savings and more with programs that pass the TRC, the benefit cost. So benefits are greater than cost. Aren't EPA's results suspect? Thinking about it. A lot of states are already getting it. Aren't they suspect?
Well, one way of thinking about this is in terms of setting the target. One could argue that the assumptions for setting the expectations for what a state will achieve with EE are conservative or low, right? A state that really does all cost-effective EE, for example, could maybe there are states that could comply with this rule simply by doing full comprehensive cost-effective EE.
Right. Yeah. So I guess that's why I'm stumbling with the idea of them being suspect. I mean, we're using our technicians are just based on what EPA is doing, which is making particular assumptions about what's possible for a given future year, and that's how the target is set through that BSER standard. If that is more ambitious than what a state can really accomplish, then it becomes hard to comply with that. If it's less ambitious than what a state is already accomplishing or what it's capable of accomplishing, that becomes easier to achieve compliance.
Right, and I guess we're speaking to the target, and then the question may be going to are the costs, the net benefits calculation suspect, and I guess to the extent that's what's intended by the question, I think these can and will be argued different ways. There probably will be arguments that the assumptions for EE that can be realized are that the costs are too high. In this, I think is it 10 cents or 12 cents per kilowatt hour? 9 cents per kilowatt hour for EE is the assumption for the cost, and there's evidence that that's maybe too high. There's arguments that we should do that EE anyways despite the rule, so don't take credit for it as part of the rule. But hey, maybe we're not doing it now. In fact, how many states you can count them on one hand, so that are really doing a comprehensive job. So I think that one could and will be argued from different sides.
Okay. Let me. I think we're running out of time for questions, or almost out. Let me see if there's anything that I can do to answer a couple last questions here. But I think we're going to stop taking questions. Are there any particular resources that you recommend on 111D? I have not yet seen something that I would say is that. Have you, Sarah? Or anybody else?
There are a few really strong blogs about, if you're interested in the legal sides of it, that I've seen.
Kind of a different
not
area
what we're covering,
nuts and bolts. So again, if anybody's seeing anything good out there, they could send us an email letting us know about that. We'd love to hear about it and share it with others. Slide 43, are you saying $13 billion in benefits over the total period through 2030? No, that's an annual. That's in 2030. What would the benefits be in that particular year? Are you also saying the denominator that you use to determine the 0.3% per kilowatt hour reduction is the kilowatt hour sales for the same period? Yes, I am. It's the kilowatt hour sales for 2030 as predicted by EIA.
So that's an annualized number for 2030 comparing the two different cases, one with the policy and one without.
That's right. Last one on here. Have you seen the Bloomberg map that purports to translate emissions rates into tons reduction? I have not seen that. Have you seen that? No. Bloomberg map. At least it's not ringing a bell. Sorry, we've seen a lot of stuff. If you want to send that to us, then be another point of discussion. So I think we're wrapping up here. Thank you so much for joining us and for the question and answer session. It's been great. Please do email me with any questions, or other people here at Synapse. We're happy to talk about these things and to dig into issues more deeply. When we close off the slides here, something will pop up that's a poll about the presentation, and ask a couple, there's only 2 or 3 questions in there that are asking you about your experience here with us today. And again, thank you so much, and thanks to the other panelists here for helping out with all the questions. I appreciate it. So, and I think we're off.